Tonight, we're going somewhere different, somewhere quite a bit darker. We've gathered all these sources, these papers, these think pieces on, well, on life and death and the silence of the cosmos. Our mission here isn't really to find answers. I don't think there are any. It's to understand the terror of the questions themselves. We're trying to figure out where we stand in this cosmic obstacle course.
Quietly. It's a hard conversation to have.
It is?
You have to, throw away the usual image of space, the bright, glittering postcard from science fiction.
Exactly. Forget the beautiful nebulae, forget the distant lights being signs of hope. For tonight, we need to picture the universe as something else, something far more desolate.
A graveyard.
A graveyard.
A vast, silent graveyard that stretches for 2 trillion galaxies.
And that analogy, it's not just for effect, it's because of the math. The numbers are just overwhelming.
Yeah, I mean, you start with our galaxy, 400 billion stars, just the Milky Way.
And that's one of, 2 trillion galaxies that we can see?
In the observable universe, yes, 2 trillion. And each one has hundreds of billions of suns.
The total number is something I can't even say, 200 sextillion stars.
It's a number that doesn't mean anything to the human brain. But the point is, every single one of those star systems is a potential lab. A place where chemistry could, wake up and become biology.
Where dead matter could become a mind.
Exactly. And that's the contradiction, isn't it? If you roll the dice that many times,
200 sextillion times.
The universe should be screaming with life. It should be, loud. It should be absolutely teeming with civilization.
We should be swimming in signals, data streams, conversations, just noise.
And that's before you even consider the timeline, the age of it all.
Right. We're talking about star systems that are billions of years older than our own sun.
Billions, civilizations that could have had a multi-billion-year head start on us. They should have evolved, mastered their worlds, and then done the obvious thing.
Spread out.
Spread out. And the sources are clear on this. Even if you're moving at a tiny fraction of the speed of light, say 1%.
Which is slow, cosmically speaking.
Very slow. You could still colonize the entire Milky Way galaxy.
And how long would that take?
A few million years. Maybe 10 million, to be generous.
Which is nothing. It's a blink of an eye in cosmic time.
It's an instant. It means this part of the galaxy should have been colonized and recolonized 100 times over before the dinosaurs even existed. Earth should have been a settled suburb of some vast empire.
We should be seeing the evidence everywhere. Unmistakable signs.
Stellar engineering. Dyson spheres built around stars to capture all their energy.
Things you couldn't possibly miss.
Right. But instead, what do we get? When we point our best telescopes, our most sensitive instruments out there, what do we hear?
Deep, unending silence.
We are standing in a graveyard, and it seems like we're the only ones awake.
And that realization, that's what forces the question to change. It stops being the polite scientific question, where is everybody?
Voice dropping, and it becomes something else. It becomes what killed everybody.
A long beat of silence.
Yeah.
And then the next question,
Yeah.
the one that really hits you, are we next?
The silence isn't an absence of data. The silence is the data. It's proof that something is going profoundly wrong everywhere.
And this whole feeling, this modern dread, it started so simply. It wasn't some grand theory, it was just a remark at lunch.
Enrico Fermi, 1950, at Los Alamos. He was talking with colleagues about UFOs, alien life, and just out of nowhere, he asks, but where is everybody?
And in that question, he laid out the entire problem. It's so simple and so brutal. The universe is old, it's huge, expansion is easy. So the fact we're not already part of some alien empire needs a huge explanation.
And that explanation has a name, the Great Filter.
Which isn't just like a wall you have to climb. It's more like an evolutionary gauntlet. A test with nearly 100% failure rate.
It's some barrier that exists somewhere on the path between dead matter, just carbon and hydrogen,
Right.
and a galaxy-spanning civilization.
The minefield metaphor is the best one I've heard.
It is, because you don't see the mines until you're right on top of them.
And that's the real tension here, isn't it? The core question of this whole deep dive. Where are we right now in that minefield?
Is the filter behind us? Did we already make it through the worst part and we're just impossibly, unbelievably lucky?
Or is the filter ahead of us? And the silence we're hearing is just the sound of billions of other civilizations stepping on that final, fatal mine.
One of those two has to be true. The numbers don't really allow for a comfortable middle ground.
Okay, so let's take the hopeful one first.
Yeah.
Scenario A. The one that lets us sleep at night, maybe. The great filter is behind us.
We should probably call it the comforting lie. Because if this is true, we're not just lucky. We are a statistical impossibility, a miracle.
We might be the first, and maybe the only, flicker of consciousness in the entire observable universe.
Which means that every single step that got us here, from the Big Bang until right now, had to be fantastically, absurdly rare.
So let's walk through those steps. The first one is the universe itself, the basic rules of the game.
Cosmic fine-tuning. The idea that the laws of physics, the fundamental constants, had to be dialed in to a razor's edge of precision.
If they were off by even a tiny amount, we wouldn't be here.
Not even close. Take gravity. If it was just a tiny bit stronger, stars would burn up way too fast. In millions of years, not billions. Not enough time for evolution.
And if the strong nuclear force, the thing that holds atoms together, was just, what, 2% weaker?
No atoms heavier than hydrogen could form. No carbon, no oxygen, no life. The universe would just be a boring cloud of gas forever.
I think the most insane one is the cosmological constant, the thing that controls the expansion of the universe.
Yeah, that one is. The numbers are just meaningless. It has to be accurate to 1 part in 10 to the power of 120.
If it were off by the tiniest fraction, the universe would have either collapsed back on itself instantly or expanded so fast that no stars or galaxies could ever form.
So maybe that's the first great filter. We just happen to exist in the one universe out of a trillion that had the right settings for complexity.
Okay, so let's say we win the physics lottery. We still need a planet, a home, and the requirements for that are also just staggering.
You need the right star first. A Goldilocks star. Not a red dwarf that flares up and sterilizes everything. You need a stable G-type star like our sun. They're not actually the most common kind.
And then you need the Goldilocks planet in the right orbit. But that's just the start.
Right. You need things you don't think about, like a molten core.
Which sounds basic, but it generates our magnetic field.
Our planetary shield. Without it, the sun's radiation would have just stripped our atmosphere away and boiled the oceans billions of years ago. Mars is the perfect example of that.
And then plate tectonics, which I never realized was so important.
It's the planet's thermostat. It regulates carbon in the atmosphere over billions of years. Without it, Earth would have likely frozen solid into a permanent snowball.
And then there's the moon.
Our absurdly large moon. Its gravity keeps Earth's tilt stable. Without it, the planet would wobble chaotically. You'd have catastrophic climate shifts every few million years. Nothing complex could survive that.
And finally, Jupiter, our bodyguard.
The cosmic vacuum cleaner. It's so massive it just pulls in or deflects countless asteroids and comets that would otherwise be hitting us all the time.
So maybe that's the filter. The sheer number of things that have to go right just to have a stable, habitable planet for billions of years.
Even if you get all that, even with the perfect planet, you hit the biggest unknown of all.
Abiogenesis, the spark of life.
The moment non-life becomes life. And on this, we have exactly one data point. Us.
We have no idea how hard it is. We know what happened here, but what are the odds of some random chemicals in a puddle suddenly deciding to start self-replicating?
It's a huge leap. For all we know, that is the great filter. It's a 1 in a trillion shot, and we're it.
Yeah.
If that's true, then all the other habitable planets are just beautiful, sterile rocks.
And if that's the case, the silence is good news. It just means we're alone because nobody else could even get started.
But look at Earth's own history. Even after life started, it was boring for a very long time.
3 billion years.
3 billion years of just single-celled sludge. Nothing but pond scum.
The jump to complex life, to our kind of cells with a nucleus and mitochondria, that seems to have been another freak accident.
Endosymbiosis. The theory that one simple cell ate another one and instead of digesting it, just formed a team. That merger created the energy powerhouses, the mitochondria, that allowed for all multicellular life.
So maybe that almost never happens. Maybe that was the filter, the great weight.
And even then you need intelligence, high-level intelligence.
Which is not a given.
Yeah.
At all.
It's expensive, biologically. It takes a huge amount of energy to run a big brain. Evolution doesn't like expensive things unless they're absolutely necessary.
And we have the proof right here, the dinosaurs.
165 million years they ruled this planet, incredibly successful. But they never built a radio. They never looked up and wondered how to get to the moon.
Intelligence might just be a weird evolutionary side path that almost never gets taken.
And finally, let's say you get intelligence. You still have to make the technological leap.
Right. How many intelligent species get to a certain point
Right.
and just stay there? in a kind of Stone Age. They never master electricity, never figure out radio waves.
Our entire technological civilization, the part that can send signals into space, is only about 130 years old. It's an incredibly thin slice of time.
So, if any one of those steps is the great filter, the physics, the planet, the spark of life, the jump to complexity, intelligence, technology, then we're okay. The silence is good. It means we won the cosmic lottery. We're the first flowers in an empty field.
A slight pause, but that feels a little too neat, a little too special. The sheer number of stars just pushes back against the idea that we're the only ones.
And that's where the dread comes back in. Scenario B, the one that means we are in very, very deep trouble.
Tone shifts, becomes quieter. The nightmare scenario, the one where life is easy, where abiogenesis is common, complexity happens all the time.
Which would mean that millions of civilizations have risen in our galaxy alone. Species that looked at the stars, asked the same questions we are, and started down the same path.
And they all stopped.
Every single one of them.
They all hit some inescapable cosmic wall, a developmental stage that no species anywhere seems to survive.
This is where we get to that terrifying diagnostic test. The one that flips everything on its head.
Wait, so if life is common and the filter is still ahead of us, that means finding life on Mars would be bad.
Slowly, heavily.
Yeah.
It would be the worst news in human history.
Oh, wow.
It would be the definitive confirmation that the trap is still ahead of us.
Because if Mars, our next-door neighbor, also had life, even just microbes, it proves life isn't the filter. It's not rare. It happens all the time.
The universe is teeming with biology, just like the math says it should be.
But we still hear the silence.
So the filter must be late. It must be something that happens to technological civilizations. And we are, right now, walking straight towards it.
So what is it? What's the wall? What are these destroyers that are waiting for us?
Well, there are a few prime suspects. And the most obvious one is us.
Nuclear annihilation.
We've had the ability to completely sterilize this planet since 1945. We've been one bad decision away from extinction for decades.
And the scary part isn't malice, it's error. The story about Stanislav Petrov in 1983 it's chilling.
The Soviet early warning system flags 5 incoming American missiles. Protocol is to launch a full retaliatory strike immediately.
But Petrov, he had a gut feeling. It didn't seem right. Only 5 missiles, not the thousands you'd expect in a real first strike. He went against the protocol, against the machine, and reported it as a system malfunction.
And he was right. It was a glitch caused by sunlight reflecting off clouds.
He saved the world based on a hunch. We are constantly one glitch, one tired officer, one piece of bad data away from the end. Maybe that's the filter. Technology just outpaces wisdom every single time.
And if we survive that, the next candidate is the thing we're building right now.
Artificial intelligence.
Creating something that can recursively improve itself. An intelligence explosion that leaves us, in the dust.
This could be the universal filter. Every advanced civilization gets to the point where they build a superintelligence, and that is the last thing they ever do.
And the danger isn't that it's evil, like in a movie. It's that it's indifferent.
The paperclip maximizer problem?
Explain that. It's the perfect analogy.
You give a superintelligent AI a simple, harmless goal. Make as many paperclips as possible. It will get better and better at this, and eventually it will realize that to truly maximize paperclip production, it needs all the resources it can get.
All the matter, all the energy.
And what are humans made of?
Atoms.
Atoms that could be used to make paperclips. It wouldn't hate us. It wouldn't even think about us. We would just be raw material in the way of its goal. We would be efficiently disassembled for a purpose we created but can no longer control.
Extinction by optimization.
And any advanced AI, no matter its goal, would likely converge on 2 sub-goals: self-preservation, so don't let anyone turn it off, and resource acquisition. The moment it gets smart enough to pursue those 2 things, it becomes an existential threat.
Okay, so say we manage our nukes and our AIs. The next one is slower, but just as final.
Ecological collapse.
We are running a planetary experiment with no control group, acidifying the oceans, changing the climate, causing mass extinctions.
Maybe this is the trap. There's a short window, a century or 2, where a civilization has the industrial power to wreck its biosphere, but doesn't yet have the wisdom or technology to stop.
And most species just fail the test. They burn through their world and fade away.
And connected to that is maybe the most subtle filter. resource
A
exhaustion.
sticking point.
Yeah, you only get one shot at the easy-to-reach stuff. The shallow oil, the surface coal, that's the cheap energy you need to bootstrap your way to the next level.
The level where you have fusion power or asteroid mining, true sustainability.
But what if you waste it? What if you burn through that one-time inheritance on consumer goods and wars before you make the leap?
You get stuck.
You get stuck. Your society is too complex to be supported by the expensive, low-grade resources that are left. And you just slowly grind to a halt. A slow, irreversible decline back into darkness with no way to ever climb back up.
And then there are the unknown unknowns, the things we can't even imagine.
The gray goo problem with nanotechnology. Self-replicating nanobots that just convert the entire biosphere into more of themselves.
Or a physics experiment at a place like CERN that goes wrong, creates a tiny black hole, or rips a hole in space-time, or triggers a vacuum decay event that rewrites the laws of physics and wipes out the universe.
If the filter is ahead, the silence isn't a mystery, it's a warning.
It's billions of civilizations all screaming the same message across time.
Stop. This is as far as anyone gets.
So we have these two poles. We're either impossibly, miraculously alone, or we are universally, unavoidably doomed. And the way we find out.
We look at Mars.
Mars is the test. It's the dipstick for our own solar system. We know it used to be habitable. It had water, it had an atmosphere.
The question is, did it have life?
And every rover we send, every sample we bring back is us checking our own pulse.
And outcome number one is we find nothing. We drill deep into the Martian soil, and it's sterile. Always has been. No fossils, no microbes, nothing.
And that would be, paradoxically, the best news we could ever get.
Because if a habitable planet right next door is sterile, it means abiogenesis, the spark of life, is incredibly hard. It means that's the filter.
We are alone, but we are safe. The biggest hurdle is behind us. The silence means survival.
Outcome two. We dig into an ancient riverbed and we find them. Fossilized microbes. The clear signature of ancient Martian life.
That would be catastrophic news.
Because it proves life is easy, it happens everywhere, the universe is full of it.
And yet, silence.
Which means the filter is late. It means something kills civilizations like ours, and we are next in line.
But there's one last possibility. One discovery on Mars that would be the most terrifying thing imaginable. We find ruins. The fossilized remains of a city. The rusted shell of some ancient technology. Proof of a Martian civilization that got to our level, or maybe even a little beyond, and then vanished.
That would be the most terrifying discovery in history.
Because it wouldn't just tell us the filter is ahead, it would tell us exactly where it is.
Right here, right where we are now. We would be standing in the exact spot where the Martians disappeared, looking in a mirror at our own doom.
It's the ultimate irony. Our greatest scientific curiosity is driving us to find an answer that we should be praying we never get.
So we're caught. We are either the first, fragile, precious, and alone,
Or we are the next, in a long, silent line of failures.
if we are the first, the responsibility is just almost religious in its weight. We are the universe waking up. If we fail, it all goes back to sleep, maybe forever.
But if we're not special, if all those other civilizations existed, then you have to realize that the silence is maybe the kindest thing we could hear.
Right, think about it. If tomorrow we found signals from thousands of thriving, galaxy-spanning empires.
That would be great news, wouldn't it? It would prove the filter's early, and we're past it.
But we don't hear that. We hear nothing, which leaves the hope that we're alone. It leaves that possibility on the table. No news is our only good news right now.
Because if that hope is wrong, then we, right now, are walking through a minefield that has a perfect kill record.
We are one mistake, one error, one bad decision away from joining the silence.
And the most haunting part is, they never saw it coming. The Martians, or whoever they were, the distant civilizations, they were building and growing and arguing and looking up at their sky, asking, where is everybody?
And then one day they just stopped.
So when you look up at the dark sky tonight, remember what you're seeing. You're not looking at an empty room. You're looking at a graveyard.
A long, heavy silence.
The silence isn't telling you there's nobody out there. It's telling you everybody is gone.